Hello everyone, welcome to this video. This is a DHCP deep dive. So we are going to be looking in this video at DORA, discover, offer, request, acknowledge, the process for a host in IPv4 that doesn't have an IP address, the process of how it receives one, IP helper address, the DHCP relay configuration. So there's a lot to look forward to in this lesson. First, and I do want to apologise. This video has been quite delayed. It should have been released on Friday, 27th November, so it's been significantly delayed. I really apologise about that. And I am working my best to get the upcoming content out as soon as possible for you guys. That's been promised, so please bear with me on that. But I'm really looking forward to this lesson. It should be really good. So let's look at DORA. So DORA is the process of how a host is obtaining an IP address. A host without an IP address is obtaining his IP address. Okay, so we go from discover from the client side, offer on the server side, request on the client side, acknowledge on the server side. So let's have a look at this example here. You've got host 1 connected to switch 1 connected to router 1. So host 1 has a this at the moment won't, if it was going to be trying to communicate, it's not going to have an IP address. So it's going to be using this 0.0.0.0, and this is a local broadcast address 255.255.255.255. So these are two special addresses that are okay for those hosts that don't have an IPv4 address. Yeah, they're like these or they kind of like, they're kind of left out. They're a bit like they're kind of special in that sense. They don't have an IP address yet, so that is reserved for them here 0.0.0.0. And then this is the local broadcast address that you can use 255.255.255.255. All right, that's the local broadcast IP address that it can use. So now when we've got this happening, you've got a host and it wants to obtain an IP address from the DHCP server, like in this case. It wants that. What's going to happen? Well, you're going to go through those phases of discover. Okay, host is trying to find a DHCP server, is discovering, and then when a DHCP server finds out that, hey, there's a host 1 here, it doesn't have an IP address, it'll offer one. If that host 1 is happy, it will request it, and then the process is completed with acknowledge. That's DORA. Now, but how do other hosts know that the DHCP server's offer message isn't for them? So when the server sees that there's a host out there, he needs an IP address, it's like, oh, I can see this guy here, host 1, he needs my help, I'm going to send him an IP address. But how do the other hosts, like for example, if you had host 3, 2, 3, 4, 5, and 6, all connected here, for example, 2, 3, 4, 5, and 6. Imagine if you had 6 hosts. How would those hosts, the other 5, know that offer message isn't for them? It's a valid question, right? It's a very valid question. Well, the answer is there's a client ID in the original discover messaging. So that identifies the host. That will identify host 1's MAC. So then when the offer message comes back to the host, the other hosts will be able to see, aha, right, it's got a client ID which isn't mine, so therefore this isn't for me, and it's discarded. The message is discarded. Okay, now I want to talk about the automatic private IP address range. So you got 169.254.x.x, right? So this is a range, okay, from the 1.0 to 254.255. So the automatic private IP address, a PIPA or APIPA, however you choose to refer to it, I'll refer to it as a PIPA. The PIPA is something that you may also see. Sometimes you may be, for those of you already have IT jobs, maybe worked in the help desk before, you might have seen that someone you get a user reports to you that their PC has lost connection to the internet, and you go onto a command line and you type in ipconfig, and you see that the IP address is starting with 169.254, and well, what do? You request a new, so you basically renew the lease of the, because what's happened is that the client has lost its IP address, and now it's not being able to get one. It's clung on to this 169.254, which is only used on that can't be used to communicate out on the internet. It can only be used within a work group, something like a work group, where you've only got maybe 2 or 3 PCs. They connected to each other, but they don't connect out into the internet. Those situations could help, but for connected internet is a no-no. We don't want to be using a 169.254. So you do ipconfig / release and ipconfig / renew to get rid of that IP address, and then request a new one from the DHCP server, and then the host receives a new IP address, and then it can communicate out to the internet again, and it's happy days, right? So a paper can be used for things like work groups, but it's not something we want to be using, because that can't allow us to connect into the internet. So 169.254 is something that's not really desirable. It's not necessarily like you're doomed or the kiss of death or anything, but it's something that it's not really something that you want to be using. But it's very important to be aware of that 169.254. Please remember those 2 numbers there. That is for automatic private IP address. So the paper process is right. You choose from the range ARP, address resolution protocol, and duplicate address destination, DAD. Yeah, I know, right? DAD. ARP and DAD are carried out, these 2 processes, right? Okay, so the ARP, address resolution protocol, ARP, I'm sure you'll be familiar with this, okay, for mapping between layer 3 IP addresses and layer 2 MAC addresses, right? So you've got a client, it's got an IP address, it wants to communicate with another client. It doesn't know but the problem is it doesn't know its MAC address. So it's looking for so it sends out an ARP message out to all the clients, and it's looking for basically saying who is this guy, who is, for example, 192.168.1.10. Let's say, for example, that's host F, for example. Host A wants to communicate with host F, okay? And when host F sees that ARP message, it will reply to it. It will send an ARP reply saying, sending the MAC address, its MAC address, and then that enables that layer 2 connectivity there between them. Okay, so ARP, duplicate address duplicate address detection. So yeah, it's basically what it does what it says on the tin. That's what it's doing. Duplicate address detection. Those 2 things are carried out, and then send and receive packets from and to other paper devices on the local network only. That's what's happening. Okay, on the local network, like a work group, for example. That's what's happening. So let's look at DHCP relay. What is actually DHCP relay all about? Well, DHCP relay is how we basically, if you got it's basically you using, like here you've got host 1, router 1, router 2, you've got host 2, server 1. You've got this guy in the middle, this router 1 here. This is helping communication between because basically host 1, when it wants to communicate with a device with this DHCP server here, that DHCP server does not exist in the subnet. So DHCP relay basically is allowing communication between hosts that don't have a DHCP server in their subnet. It doesn't have one. It's like, you can kind of think of it as like I think of it a little bit like an orphan. Like, for example, it doesn't have a parent. Okay, so router 1 is basically, it's a point in contact with the DHCP server. It's enabling it to be able to contact a DHCP server. It's basically acting as a middleman here, So what happens is, so this at the moment doesn't have an IP address. It's got an IP address of 0000, right? And it wants to send it sends a discover message out to 255.255.255 right? So it sends a discover message out. That discover message now goes to here, router 1. Okay, it can see now that, right, okay, this basically helps host 1 out, because it will then relay because router 1 will enable that connection to the DHCP server, and then from the so now it's going to be sending message to the DHCP server from itself, 192.168.1.1, is using the helper address. The helper address is the address of the server, okay, and that's something that needs to be configured on router 1 so that router 1 knows to send packets that are coming from the gigabit Ethernet 0.0, its ingress interface here. For those hosts that are sending messages to it from that interface, to send them out to that IP address, okay, 2.11. So that's what's happening. So very important we know that. And then what happens after? Well, the DHCP server is going to reply, right? So it's going to send packet here to router 1, 192.168.1.1, and then router 1 will then send back to the host, and now and then that's happy days, okay? But remember, look, it's sending out there 255.255.255 and 192.168 from 192.168.2.11. So that's what's happening here. Sorry, this IP address is actually 255.255.255. That should be 255.255.255. Sorry, like you have here. My bad there. Apologies. Okay, that's 4 245s there. Sorry, don't. Okay, you might be wondering why is there only 3. It should be 4 245. Sorry, that's a mistake there on the whiteboard. But everything else is fine. So that's the DHCP relay process there. So what we need to remember is that information that's stored in the DHCP server is the subnet ID and mask, reserved addresses, the default router, okay, the default gateway, default router, same thing, the DNS IP addresses. Okay, this information has been stored in the DHCP server. There's 3 allocation methods that are being used. Dynamic allocation is DHCP server when a DHCP server leases an IP address. And automatic allocation is DHCP server permanently assigning IP address to a client from its pools. Okay, and static allocations are when a network admin is manually assigning an IP address to a client, and the DHCP server conveys the IP address. Okay, so that's static allocation. All right. So let's go through this again. Dynamic allocation: the DHCP server is leasing an IP address. Automatic allocation: the DHCP server is permanently assigning an IP address to a client from its pools permanently. Okay. And static allocation is a network admin manually assigning an IP address to a client, to a host, and the DHCP server conveys the IP address. So what we're doing here, we're doing dynamic allocation, okay, with DHCP for this lesson. So we're concentrating on that at the moment. Configuring DHCP relay. So we've got a lab now. We've got router A, C, B, and D. Okay, so router A, router B. Okay, you got 2 LANs coming out that are connecting to these routers, and then you got router C here, which is which is connected off these 2. So let's look at DHCP relay. So DHCP relay is a feature where a router relays DHCP messages between a host in a remote subnet and a centralized DHCP server. Okay, like I said, it's basically acting as a middleman to relay that DHCP message from the host that doesn't have a DHCP server in its subnet to a DHCP server, right? So we use the IP helper address subcommand to be able to enable us to do this. Okay, the IP helper address subcommand, like we did here. Okay, this would have been configured IP helper -address. Okay, 192.168.2.11. This the IP address of this server that would have been configured on router 1. Okay, that's what needs to happen. So we're going to be looking at DHCP relay configuration now. Okay, so configuring DHCP for IP networks. Okay, so on router A, we are now going to be issuing the commands to display the DHCP section of the running configuration. Okay, we need to review the DHCP configuration, answer these questions. What IP address is explicitly excluded from the DHCP configuration? What is the address why is the address you noted above excluded? What is the name of the DHCP pool configured on router A? What network parameters are specific to the DHCP pool? Okay, so those are things that we'd be looking at. Okay, so what happens now is on router A, we issue show running -config pipe section IP DHCP. Okay, that shows just the DHCP part of the configuration. Okay, and now what we can see is IP DHCP excluded address 172.16.10.17, IP DHCP pool _1, network 172.16.10.16, and sorry, 252.240, default route 172.16.10.17, domain name bosun.com, these two. It might seem like a lot of information to start off with, but you'll get used to seeing this, so you get familiar with what kind of output you're going to see from the DHCP part of the running config. Okay, so we can see now that this address 172.16.10.17, that is excluded. That's on the exclude list, right? Okay, so it should not be allocated to DHCP client. Okay, IP DHCP pool underscore IP DHCP pool underscore 1. That line in the output of the show running config command indicates that a DHCP pool named pool1 has been created on router A, and there's on the lines underneath that relates to that pool. Okay, so that network, you see network 172.16.10.16, right, 252.252.240 or /24, that okay, so that IP address is there configured. You can see the default gateway there, default router 172.16.10.17. Okay, that's within the subnet. That's been configured. So that's fine. That's a valid IP address to configure. And then you see the domain name is bosun.com, and you can see the lease time is 2 days. So that's just breaking down the output there for the DHCP part of the running configuration. Okay. Let's just briefly look at let's look at this now. Let's now look at the show running config section DHCP in this lab now. So let's do this. Let's actually enter this rather than showing you a paste on the screen. But there, you can see this is how the output would show. If you just show running config, you'd see config just related to so many things. So we don't want to see all that. So we just want to see the DHCP part related to DHCP. So that's what we do. Show running config. Okay, remember there's a hyphen between running and config. Show running hyphen config pipe section DHCP. Pipe section DHCP. Okay, so you use pipe section DHCP. You're just passing it for DHCP output. So that's what happens. Let's do the same thing on router B now. Okay, so show running hyphen config and pipe section DHCP, and now we see DHCP part of the configuration. So let's configure DHCP relay agents now. Okay, so the IP helper address command that's used, right? It sounds okay, and configuring DHCP relay. Don't worry, I was intimidated. It does sound intimidated, but it's not. Okay, what we need to do is to configure the IP helper address command. We just identify the interface that need the feature. Remember, if I showed you when I showed you on the whiteboard, you had that interface that was connected, the ingress interface for router 1. That we needed to configure DHCP relay. We needed to configure the IP helper address command. There wasn't much to okay. That was not a very difficult thing to grasp or anything. We just need to configure the IP helper address command on that router, so then the router knows that to relay any DHCP discover messages out of his egress port, so that it goes to a DHCP server, so that request is fulfilled, right? So that discover message is actually fulfilled. So DHCP clients exit in the subnet, and DHCP servers do not exist in the subnet. Sorry. Exists in the subnet, not exits in the subnet. DHCP clients exist in the subnet, and DHCP servers do not exist in the subnet. That is when you need the DHCP relay feature. Okay, so so that's the whiteboard again. So like here, router 1, we'd configure the IP address help address command here, so then it knows it to relay any DHCP discover messages to the DHCP server. So that's actually now gone on router A. Let's issue the commands to remove the IP address from the exclusion list. Okay, so no IP DHCP excluded hyphen address 172.16.10.17. Okay, 17. 172.16.10.17. that is taking it out of the excluded list now. We're not excluding it, we're taking it out of the excluded list. And now we do that show running config. Okay. We do that show running config now. And what do we see here? Yep. So we see output. Okay, we see information about that pool. Now, excuse me. What do we need to do now? Let's now go into router A and issue the command to remove the pool. We're going to remove the pool now. Okay, no IP DHCP pool 1. Okay, that's all we need to do. That's it. So that's remove the pool now. So issue the commands now to remove the IP address from the DHCP exclusion list on router B. Okay, so similar thing, no IP DHCP excluded address 172.16.10.33. Okay, that's what we need to do. And now let's go in. Let's go back into global configuration mode. Show running config. Pipe section DHCP. Whoop, sorry, wrong mode. Let's go back and let's now do in front of that. Okay. Right, so next up now, let's go into router B and issue the commands to remove the DHCP pool. No IP DHCP pool 2. So that's what we do there. Let's remove the DHCP pool now. Class 2.5. Now what you have apologies, it's not that clear. So we've removed the parameters configured for DHCP. So that should say now you have removed the parameters configured for the DHCP on router A and router B. Should you disable the DHCP service on them as well? Why not? Should we disable them? Should we disable the service just because we removed the parameters from router A and router B? Should we disable service? The answer is absolutely not. We should not be doing that. Okay, you should not disable the service, right? If you disable DHCP on the router, then it will not operate as the relay agent. And we want to configure. We're supposed to be configuring a relay agent. So on router A, we need to issue the commands to configure the router to forward DHCP messages received on its fast Ethernet 0/1 interface to the DHCP server on 172.16.10.1. So interface fast Ethernet 0/1. Interface fast Ethernet 0/1. And now IP helper address 172.16.10.1. Okay, configuring that's the key bit here. That's for configuring the IP helper address. And now we've done that bit, right? We've configured the help address now. So we need to issue commands to configure the router to forward DHCP messages received on its fast Ethernet 0/0 interface to the to the DHCP server at IP address 172.16.10.5. So interface fast Ethernet 0/0. Okay. IP helper address 172.16.10.5. Okay. And now let's move on to task 3. So we need to configure router C as the DHCP server now. Okay, we've configured the DHCP. We configure the help address now on router A. Okay, router A, right? Router B, we've done that on router B. Now we need to go into router C, configure that as the DHCP server. Okay, remember, let's go all the way back to the whiteboard. Sorry, not the whiteboard. We need to go back to the actual topology I wanted to show you. but the topology, you've got route A, route B, route C. So we'll configure these two guys as the relay agents now. We need to configure this guy as the DHCP server. So let's go back to task 3 now. We're on task 3, configure route C as the DHCP server. So we need to issue the commands to configure the router to respond to DHCP requests by enabling the DHCP server process. We enable, go into global configuration mode. And now we do service DHCP, right? Service DHCP. Okay, done it. Service DHCP. That's what we need to do. So, if the DHCP server process were disabled in route C, you would find the no DHCP service command in its running configuration. The no DHCP service command in its running configuration. Now let's issue the commands to configure the DHCP server to not allocate the IP addresses that are assigned to router A's fast Ethernet 0/1 interface or router B's fast Ethernet 0/0 interface. Okay, those IP addresses we don't want to be assigning out of the okay. So those now need we need to protect those. Okay, we need to make sure those are reserved. So what are we going to do? Okay, we can see these IP addresses now in our showing IP interface brief table. Okay, we can see the router A's fast Ethernet 0/1 interface IP address there. So let's go into in router B to do the same thing. We can see it here, 0/0 IP address, fast Ethernet 0/0's IP address there. We can see that as well. So what do we need to do? What do we need to do? Well, let's take a look. So what are we going to do? Let's take a look. Sorry, apologies. So we looked at router A, right? We're looking at router B. Two IPs that we don't want to be giving out. Sorry, and so in task.3.3, if you issue the commands to create a pool on a device and that pool already exists, what would be the result? Okay, sorry. So something isn't right here. There should be another part to this. There should be a part here where we talk about how the DP server is not going to be allocating those IP addresses. There should be some configuration to stop that from happening. So sorry guys, that looks like it's been missed out of this. It looks like it's been missed out. So apologize there. That should not be the case. That should not be the case. You should be able to see that we should be able to there should be a bit more for task 3.2. So if you go, bear with me, let me just check something, and I'll confirm that for you. What's we're actually doing here. Thanks for bearing with me. Sorry, it should be in 2-3 days before since I prepped this lesson. So thanks for bearing with me, but I'll confirm that for you. But let's just think about what we're going to be doing next. If you issued the commands to create a pool on a device and that pool already exists, what would be the result? Okay, if you issued the commands to create a pool on a device and that pool already exists, what would be the result? Let's have a think about that. Well, it's very simple actually. We just enter the DHCP configuration mode. Just enter DHCP configuration mode. That's all that's happening there. Just enter DHCP configuration mode. So there's not much change or anything. You just enter the configuration mode if you were to do that. So thanks for bearing with me, guys. I really apologize for the confusion. So go back to task 3.2. We needed to configure the DHCP server to not allocate IP addresses that were assigned to routers A's fast Ethernet 0/1 interface or for router B's fast Ethernet 0/0 interface. So what was happening? Sorry, I'm just having an issue here. I'm just trying to pull the answer. So task 3.2, right? What needed to happen was simply IP DHCP excluded address 172.16.10.17 and 172.16.10.33. That just needed to be configured for both interfaces. That's all we needed to do. Sorry, it was quite late, so I had to quickly check. I had to quickly check my lab notes there. Sorry about that. So that's all we needed to happen. Sorry, looks like it wasn't captured here. But task 3.2 is very simple. We just, if this would be the case, all what you need to do, if you create a pool and that pool already exists, you just go into the configuration mode for that pool. Now, task 4 is issue the commands to create DHCP pool named pool1 with the following parameters. We need to allocate the address range assigned to the fast Ethernet 0/1 interface of router A. You set the default gateway parameter equal to the fast Ethernet 0/1 interface of router A. And then assign a domain name of bosun.com and configure lease duration of 48 hours. So that sounds intimidating, but it really isn't. It's really nothing that we should be worried about. We go into global configuration mode, and then we enter IP DHCP pool _1, and okay, so that will create that pool now. We need to allocate the address range assigned to the router 1's interface of fast Ethernet 0/1. Okay, so network 172.16.10.16 255 255 255 240. Okay, allocate the address range as assigned to fast Ethernet 0/1. We need to set the default gateway parameter equal to fast Ethernet 0/1 interface of router A. Assign a domain name of 48 hours. Sorry, at least duration of 48 hours, domain name of bosun.com. Okay, so 48 hours, we'd configure that in days. Okay, we don't want to configure 48. It's 2 days. It's 48 hours is 2 days, and you wouldn't configure more. If you had 25, for example, you say you had 48 hours, 72 hours, you would configure that in days. So you would enter 2 or 3, depending on how many hours that becomes in days. How many days that becomes now. Sorry, I'm not quite with it at the moment. Let's go into task 3.5. Issue the commands to create a DHCP pool named pool2 with the following parameters. Right, so we need to allocate the address ranges assigned to the fast Ethernet 0/0 interface of router B. You set the default gateway parameter equal to the fast Ethernet 0/0 interface of router B. Assign a domain name of bosun.com and configure lease duration of 30 hours. So let's configure the address range. Set the default gateway equal to that fast Ethernet 0/0 interface. Assign a domain name. Bosun.com. Create lease duration of 30 hours. Okay. Firstly, let's create the range. We need to create the pool. Okay. Allocate the IP address range. We need to set the default gateway, default router. Okay, and that needs to be the IP address of the fast Ethernet 0/0 interface. sign the domain name boson.com, and configure lease duration of 30 hours, right? So that, okay, is happening here now. So okay, so we create that pool 2, and okay, this is okay. So when root C, which is going to be our DHCP server, we create that pool. Okay, we create it in that range. We specify the default router, right? We specify the default router, the default gateway, domain boson.com, and lease duration is 30 hours. So we do configure that in 1 day and 6 hours. Okay, 1 day and 6 hours, 24 hours in a day, 6 hours makes 30 hours. That's how we'd configure it. You wouldn't do 30. Okay, like I said, if you got more than 24 hours, now you need to if you 24 hours, 48 hours, you need to configure that. If you had you need to configure that in days. Okay, once you go past that 24 hours, you now configure 1 day. If you got 25, 26 hours, then it's one for 25 hours, 1 day, 1 hour, or 1-2 for 26 hours, 1 day, 2 hours, like that. In this case, it's 30 hours, so 1 day, 6 hours, so we do lease 1/6. Okay, now let's allocate the address range assigned to fast Ethernet 0 interface router B. Set the default gateway parameter equal to fast Ethernet 0 interface of router B. Assign domain name, configure lease duration. Sorry, that's a duplicate slide there. Let's now configure the DHCP clients, right? So on each PC connected to switch A, issue the commands to configure the PC as a DHCP client. So on this PC, we go to IP, we do ipconfig / DHCP. Okay. Now this you gotta remember these PCs in this Boson NetSim software, they've got their own command line software, which is kind of uses which kind of takes from Windows Mac terminal, so Windows CMD, Mac terminal, and Linux. So okay, so please check don't worry, I will have a video coming on actual networking commands. So I wouldn't don't focus too much on the network commands here, because this is a custom software that's supposed to basically emulate a PC terminal. So you don't get too focused up on those commands. I'll have a new video coming for commands when it comes to network related commands for Windows, Mac OS, and Linux. So please stay tuned for that. So ipconfig / ipdhcp, that's just to configure the PC as a DHCP client. That's what's happening. Again, we do that on this PC now connected to switch B, right? So okay, and ipconfig / ipdhcp, and what happens is you see here interface Ethernet 0 assigned DHCP addresses 172.16.10.36. Interface Ethernet 0 assigned DHCP address 172.16.10.36. Mask 252.240. So happy days, it's got an IP address now. So task 2.4.245 router D issued the commands to configure DHCP to request a 1 day IP address lease on its fast Ethernet 0 interface, and router D issued the commands to configure the fast Ethernet 0/0 interface to act as a DHCP client. Okay, so let's get to request the lease, a 1 day lease. So IP fast Ethernet 0/0. So interface fast Ethernet 0/0 IP DHCP client client lease 1 IP address DHCP. Okay, that's what we need to do. That router D is acting as a client. Okay, router D. If I go all the way back, I can show you guys. That was, if I can find the topology, that's here. So we're configuring this guy as a client. So let's go all the way back now. Right, so we have configured that guy. If I can find, sorry. So we configured that now as a DHCP client. We configured its lease of 1 day. Okay, the last bit is just verify the DHCP server functionality. So we can use show IP DHCP binding, this command on router C to examine the IP address dynamically assigned to DHCP client. So show IP DHCP binding, this command displays the mapping between DHCP assigned addresses and the associated client identifiers. The command output also indicates the scheduled expiration date and time for each lease. Okay. And the following sample output indicates that a client has been assigned an IP address of 172.16.10.18 automatically. Has been assigned an IP address of 172.16.10.18 automatically. You can see that here. So you can, okay, so basically in a nutshell, this command lets you see the IP addresses that are assigned to DHCP clients, that are dynamically assigned to DHCP clients. Okay, just shows you that mapping. Okay, and it indicates the scheduled expiration date and time for each lease. Okay, IP DHCP server statistics, this is a useful command. Okay, and we can see all these DHCP messages, okay, stats related to that. Okay, and we can see information related to memory usage and binding. So show IP DHCP pool, another useful command, just to see information related to our pools. These are some important commands to know then. Show IP DHCP server statistics, show IP DHCP pool, show IP DHCP database. So things that it's good to play with these commands in the labs to get familiar with these. So that brings me to the end of this video. So thank you so much for watching. Thanks for bearing with me. I apologize again, this video was quite delayed, and sorry there were a few mistakes in it. But I hope you found this video useful. It was quite a long video, but I think we've covered quite a lot when it comes to that configuration of relay agents. So I hope you've got comfortable with the process of doing that. So I'll see you guys in the next video. Thanks so much for watching. Take care. Goodbye.